Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today, problem number 4 from the last exam LTAM in the written answer section. CTI is a life insurance company that plans to issue a new high-volume, low-sum insured term insurance policy through direct marketing. Its current business is predominantly traditionally brokered term insurance. CTI assumes the following for calculating premiums and reserves. For brokered policies, mortality follows the standard ultimate life table and expenses are 8% of each premium. For direct marketed policies, mortality follows the standard ultimate life table with a 5-year addition to the policyholder's age. Expenses are 3% of each premium. Interest rate is 5%, which is the interest rate in the standard ultimate life table, so that's important and useful. Premiums are calculated using the equivalence principle. Question A. Explain why the mortality and expense assumptions are different for the direct marketed policies compared to the brokered policies. Now consider a fully discrete direct marketed 10-year term insurance policy of $50,000 issued to a 40-year-old with premium P. Question B. Let K star denote the quoted future lifetime of 40-year-old. Write down the gross loss at issue random variable in terms of K star P and interest rate functions. C. Show that P is equal to 57 to the nearest 1. You should calculate your answer to the nearest 0.01. Part D. Question D. First part. Show that the standard deviation of the present value of the benefit is 4088 to the nearest 1. You should calculate the value to the nearest 0.01. 2. The standard deviation of the gross loss at issue is 4088.5. Without further calculation, explain why the standard deviation of the gross loss at issue is very close to the standard deviation of the benefit. E. Question E. CTI would like to offer a revised direct marketed 10-year term policy where the annual premium is in the first 5 years is 1/2 of the annual premium in the last 5 years. Show that the initial annual premium for a 50,000 policy issued to 40-year-old is 40 to the nearest 10. You should calculate the value to the nearest 0.01. And part F, question F. CTI issues 5-year term insurance policies of 50,000 by direct marketing. At most ages, the premium for the policy is greater than the initial premium for the policy described in Part E. Therefore, the new policy is expected to be very popular. Explain why CTI might not launch this product despite its anticipated popularity. And here is the solution. For Part A, mortality and expense assumptions are different for the direct marketed policies compared to the brokered policies. From mortality, direct marketed policies typically offer relatively low benefits with little or no medical evidence, except for a standard questionnaire. So they're called non-medical for this reason, because there is no medical examination, there is no gathering of medical evidence. Just issue a policy, but you have to make up for it that you may get people who have bad health. And this creates a potential for adverse selection. Adverse selection is the situation where the people who select to buy from you are bad risks, because you make it possible for them by not having the medical evidence. And because of that, insurers assume higher mortality for these policies. For expenses, there is less underwriting done on direct marketed policies, and typically there are lower commissions, hence the expenses for writing new business are lower. And that's the reason why direct marketed policies are offered, because you just cut the expenses significantly, and you hope that you will be able to handle mortality, which is very likely to be worse, and balance the two. Part B. Recall that P is the annual gross premium. Let us denote the gross loss at issue random variable by LG. So we have LG equal to 50,000 times 1.05 to the minus K star plus 1, minus 0.97, that's premium after expenses, P A double dot angle K star plus 1 for K star equal to 0 through 9. And then when K star is 10 or more, that's just minus 0.97 P A double dot angle K star plus 1 because the benefit is no longer paid. Since for direct marketed policies, mortality follows the standard ultimate life table with a 5-year addition to the policyholder age, we have K star equal to K40 plus 5, so K45, where K45 is obtained from standard ultimate life table. Part C. Based on the expected value of LG being 0, we have 50,000. A 45 colon angle 10 with 1 above the 45 indicating term insurance equal to 0.97 times P A double dot 45 colon angle 10, so that P is equal to 50,000 A 45 colon angle 10 1 above the 45 over 0.95 times A double dot 45 colon angle 10. And we write the term insurance as 50,000 A45. Well, actually, we'll write the numerator as 50,000 A45 minus 10 E45 times A55. And then all of the numbers that we have there now can be obtained from the standard ultimate life table. We look them up, plug them in, and do the calculation. This comes out to be about 56.972758, or approximately 57. For part D, part 1, let's write Z1 to be 1.05 to the minus K star plus 1 for K star equal to 0 through 9, and 0 otherwise for K star equal to 10, and so on. And Z2 to be 1.05 to the minus K star plus 1, just like before, for K star equal to 0 through 9. And then 1.05 to the negative 10, where K is bigger. So this is an endowment insurance type of policy. And the reason why we do this is because a 10-year annuity relates to the endowment policy, not to term insurance through the David Ricardo formula. So we're going to use that. Then the variance of Z1 is equal to 2A 45 colon angle 10 upper 1, and we will be using SULT, Standard Ultimate Life Table data. And that's why we can refer to 45 in the age. So that's why this mention of SULT everywhere. Minus A 45 colon angle 10, 1 above the 45 squared. Because Z1 is just term insurance, and then we write this as 2A45 minus 1.05 to the negative 10 times 10E45 times 2A55 to get the term insurance single benefit premium, so single net premium, this part. And this guy is written as A45 colon angle 10 minus 10E45 squared. Those numbers are in the table, so we plug them in. When we do the calculation, this comes out to be about 0.00686055. The variance of the present value of the benefit is 50,000 squared times this amount, or approximately 16,715,137.62, and the standard deviation is the square root of the variance, approximately 4,088.41505. For the second part, the standard deviation of the gross loss at issue is 4088.5. This is very close to the standard deviation of the benefit. Note that LG is 50,000 Z1 minus 0.97 P times 1 minus Z2 over D. Note that, sorry about that. Therefore, the total variance will increase by the variance of the expected present value of the net premiums and twice the negative covariance between the expected present value of benefits and the expected present value of net premiums. Note that premiums are only about 0.1% of the benefit, hence the total variance will increase by a very small amount. In the case of survival for 10 years, there will be no benefit and 10 premiums paid. In case of death, 50,000 benefit is paid with a relatively small additional uncertainty about the expected present value of premiums received. Thus, the variance is almost entirely due to the uncertainty about the 50,000 benefit. This part here, it's very, very close to the overall variance of this expression. Here's part E. So let us write G for the premium paid during the first 5 years, because we assume that the expected present value of the gross loss at issue is 0, as a form of equivalence principle. We have 50,000 A 45 colon angle 10 with 1 above the 45 equal to 0.97 G times 2A double dot 45 colon angle 10 minus A double dot 45 colon angle 5. And that's because the premium in the first 5 years is half of what it is in the last years. That's the expression for that. So it's really G the first 5 years and 2G after that. And therefore G is equal to 50,000 A 45 colon angle 10 1 above the 45 over 0.97 times 2A double dot 45 colon angle 10 minus A double dot 45 colon angle 5. Well, A double dot 45 colon angle 10 is in the table, but the same thing for 5 years is not, but we write it as A double dot 45 minus 5E45 times A double dot 50. All of those are in the table, and we write the term insurance as endowment minus pure endowment. And then all of the numbers are in the table. We look them up, plug them in, and get approximately 39.5978757. That's almost very close to 40. And now part F. With this 10-year policy, policyholders have an option to continue or renew at time 5 and pay a lower premium until then. A policyholder, because the premium after that is twice the initial 5-year premium, a policyholder age 40 could buy the 10-year term with an initial premium which is less than the premium for the 5-year term. And at time 5, he or she could lapse the policy if coverage is no longer needed. And of course, that would be a person who is likely to be in better health, not worried about possibly needing insurance later. So the bad health customers will remain with the company. Continuing coverage is also an option if he or she can qualify again. Buying a new 10-year term policy would be cheaper for most ages than keeping the original policy in force. If he/she cannot qualify, maintaining the original 10-year policy by paying the increased premium is an option, one that is not available for the 5-year with a 5-year policy. This creates a risk of anti-selection, where healthy policyholders leave and get another cheaper policy, while policyholders with higher mortality remain. So the company is not going to really like issuing policies like that. Please remember this is copyrighted material. The problem comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.